Yeah, hello guys. We are meeting once again. Our topic for today it's steam plant, power machines, N6. Its activity 6.1. The textbook is by Hegner and Detroit. So the question reads: a steam plant consisting of an economizer, evaporator, and superheater generates 7,560 kgs steam per hour. Coal with a heat value of 35,100 kilojoules per kg is used at a rate of 840 kg per hour. Temperatures of feed water entering and leaving economizer are 41.6 degrees Celsius and 99.6 degrees Celsius, respectively. The steam leaves the evaporator 95% dry. The thermal efficiency of the plant is given as 70%. Temperature of the flue gas at the chimney base is given as 225 degrees Celsius. The temperature of the boiler room is 25 degrees Celsius. The specific heat capacity of the flue gas is given as 1.045 kilojoules per kg Kelvin. Our air fuel ratio is given as 18:1. Now we can summarize the data of what we are given so that as we are solving the problem, it becomes quite easier. So let's see what are we given here. We are given, this is what we are given. I hope it's visible. We are given the following. This is what we are given. We have our economizer at this point, and then we have our evaporator, which is the same thing as our boiler. And then after economizer, our boiler, we have our superheater. So I hope it's clear. That's our boiler is clear. So this becomes our H1, our H2, our H3, and this is our H4. So H3 is the same thing as the enthalpy of wet steam. H4 is the same thing as the enthalpy of superheated steam. Now, if you check on the question here, we are given the following. At the inlet of our economizer, the temperature is said to be 41.6 degrees Celsius. But the temperature leaving the evaporator, in other words, it's leaving the economizer, entering the evaporator, is said to be 99.6 degrees Celsius. That's what we are given. What else are we given? The efficiency of the plant. So plant efficiency is said to be 70%. What else are we given? The steam leaving the evaporator or the boiler is said to be 95% dry. Therefore, our dryness factor, which you can use the symbol Q or X, it becomes 0.95, just divided by 100. And then we are also given the mass of steam. The mass of steam is said to be 7,560 kg per hour. And then our mass of fuel or coal, is given as 840 kg per hour. Our heat value is said to be 35,100 kilojoules per kg. What else is necessary, which we can put? Okay, our boiler room temperature temperature at inlet of or inside the boiler room temperature is said to be 25 degrees Celsius. And the temperature of flue gases, temperature of flues at chimney base is said to be 225 degrees Celsius. What else are we given? We are also given a specific heat capacity. Our CP of flue gases is 1.045 kilojoules per kg. So that's what we are given at our disposal. So the first question says, calculate the specific enthalpy of superheated steam leaving the plant. Then determine the pressure and the temperature of this steam from the steam tables only. So that's our A. So on our A, we are supposed to determine our H4, the specific enthalpy of the superheated steam. That's our H4 or our HSU. That's what we are supposed to look for. Now to get our H4 normally or our HSU, if all our pressures were given and all our temperatures were given, it was going to be easy, but still we can solve this problem even if our pressures and the temperature of steam is not given. So we can use our formula, but plant efficiency equals to mass of steam into our HSU minus our H1 divided by our mass of fuel times our heat value. Now, if you check here, because we are already given the temperature of 41.6 degrees Celsius as the temperature entering the economizer, we can now come here and then get our H1. H1 at what temperature? 41.6 degrees Celsius. So you need to go to a steam table at 41.6. So if you go to a steam table at 41.6, you find that our H1 is 174 kilojoules per kg. The second step is to get our H2. H2 at what temperature? The temperature entering evaporator or leaving superheater, rather leaving economizer was said to be 99.6 degrees Celsius. So we go to our steam table at 99.6. 99.6. So our HF at 99.6 is 418. So 418 kilojoules per kg. The second step which can look for, we can get our H3, which is same thing as our H weight. Our formula becomes HF plus Q times our HFG. But the challenge that we are going to have here, we only have the dryness factor, we don't have our HF or our HFG because our temperature is missing. So before we think of doing much, let's then get our H4 here. It will help us to find the other missing values. Now our efficiency here of the plant was given as 70%. If we divide by 100, which becomes 0.7. Our mass of steam was given as we said it's 7560 into our HSU. That's what we are looking for. That's what we are looking for, our HSU minus our H1, we got it as 174. Here we divide by our mass of fuel or coal, which is given as, we say it is 840. Our heat value, it was 35,100. So from there, we can make our HSU subject of the formula. which becomes 0.7 times, just cross multiply, 840 times 35100. We divide this by 7560 plus our H1, which is what? 174. Let's see what are we going to get here. So we have 0.7 times 840 times 35110 over 7560 plus 174. I'm getting something like 2904 kilojoules per kg. Now we are sorted. We now have our HSU. Once we have our HSU, this is the most important thing which we needed. Now, using your steam table, you need to move as fast as you can. Using a steam table, you go to your superheated steam table. At 20, you look for the enthalpy of 2904. So you must go to the superheated steam table. So you need to try to move a bit fast so that you can get it. We are looking at our HSU at 200 and what? 2904. So if you look HSU 2904, so our HSU, if you look, the temperature is 3000. Oh, is it 3000 here? No, it's not 3000. Perfect. If you go to your steam table, you find that 2904, the pressure is, so at 2904, our pressure is 2000 kilopascal. Then let's check what's our TSU. Our TSU at this one is 250 degrees Celsius. So you must try to move a bit fast so that the enthalpy or your HSU which you go to the superheated steam table, you look for it very quick. Now we are sorted. We have our HSU and our the plant pressure as well as the superheated temperature. Now we can get our H weight because we now have our pressure. So we can say therefore H weight equals to HF plus Q times our HFG. The pressure is now at what? 2000 kilopascal. So we go to our superheated steam table, or rather to our normal steam table. We look for 2000. We look for 2000 kilopascal. My 2000 is here, so we look for our HF. Our HF, I'm getting my HF is 908. Our dryness factor, it was given as 0.95. HFG at 2000 HFG, I'm getting 1889. 1889. So let's see what are we getting there. So I have 908 plus 0.95 times 1889. So I'm getting 2702.55 kilojoules per kg. So we are sorted because our H4 is now there, which we got as 2904 kilojoules per kg. So we have all our enthalpies, our H1, our H2, our H3, and our H4. So we can reflect once again on question 2. We can reflect once again on question 2. We check what they said they need. They also need Oh, so we have the temperatures and the pressure. So we are fine on number A. So we can go to number B. What do they want us to look for number B? Number B, they want the specific heat capacity of superheated steam in kilojoules per kg. So they want us to get our CP. So we have our formula HSU or H sup equals to Hg plus our CP into TSU minus our TS. Our pressure we now have it, which is 2000 kilopascal. So we go to our steam table at 2000. Let's go to our steam table at 2000. What's our Hg? It's 2797. So it's 2797. And then our H4, we say it is 29. Our H4 is 2904. So we are looking for our CP, our TSU. We got it here, which we said it's 250. Our TS, we go to 2000, we get our saturation temperature, which is 212.4. So we can now look for our CP. It's now easy for us to look for our CP. So CP equals to 2904 minus 2797 all over 250 minus 212.4. So let's see what are we getting there. 2904 minus 2797 divided by 250 minus 212.4. I'm getting 2,846 kilojoules per kg Kelvin. So we now have our CP. Now let's reflect on number C. Now on number C, they want us to calculate the total heat to each component of the plant and in the flue gas at the chimney base in kilojoules per kg fuel. So we need to have our heat transfer in the economizer, heat transfer in the evaporator, as well as the heat transfer in the superheater. So we have everything at our disposal. So number C, we can say Q economizer equals to MS over MF into H2 minus H1. Remember, when you calculate the heat transfer in the economizer, it is the outlet of economizer minus the inlet of the economizer. The ratio of the mass, it was given as 7560 over 840. Our H2, we said it's 418 minus 174. So let's get heat transfer in the economizer, which is 7560 divided by 840 times 418 minus 174. So I'm getting my answer as 2196 kilojoules per kilojoules. So that's what I'm getting is my answer. That's what I'm getting. 2196 kilojoules per kg. And then we need our Q evaporator. Q evaporator, we do the same thing. Our Q evaporator, it's MS over our MF into evaporator. We are here on our evaporator. So it's outlet minus our inlet, which is H3 minus our H2. Our mass is 7560 over 840. H3, we said our H3 is 2704 minus H2 418. So let's get our answer. So we are saying 7560 over 840 times 2704. Rather H3, it's 2702.55 minus, yeah. So it's 02.55 minus 418. I'm getting 20560.95 kilojoules per kg. So we have our Q evaporator. The next thing that we need to look for is our Q superheater. That is our last component. So Q superheater equals to MS over MF into H4 minus H3. H4 minus our H3, ratio of the mass 7560 divided by 840 into 2904. 294904, that's our HSU, or our H4 minus H3, which we say it is 2702.55. So let's see what are we getting there. 2904 minus 2702.55. So I'm getting 13.05 kilojoules per kg. So we have the heat transfer in the economizer, the heat transfer in the evaporator, and then the heat transfer in the superheater. The last part is to calculate the heat transfer in the flue gases, because the question says as well as the heat transfer in the flue gas at the chimney base. So we can use we are Q flues equals to MF times CP flues into our change in temperature of flue gases. Our mass, we have 18 plus 1. That's our FUO ratio. The CP was given is 1.045. The temperature of the flue gases, we are given 225 at the chimney base minus the temperature inside the boiler house. So it's 225 minus 25. So 225 is the temperature at the chimney base minus 25, which is the temperature inside the boiler. So let's get our answer. 19 times 1.045 times 225 minus 25. So I'm getting my answer is 39.71 kilojoules per kg. So we are done with that part. The last question, our D, they want the temperature of the flue gas entering the economizer. The temperature of the flue gas entering the economizer. Now, if you check on the question here, the temperature at the chimney base was given as 225. So we are going to write our formula as QF equals to M times C into T in minus T out. The question says calculate the temperature of the gas entering, of the flue gases entering the economizer. So our formula rather becomes T out minus our T in. So our Q for flue gases, we got it. Remember, we need to calculate the temperature of the gas entering the economizer. So we need to be a bit vigilant nyana here. Our Q economizer, that's the one that we are supposed to use, the energy transfer through the economizer, which was given as 2196. And then our mass, remember it's mass of flue gases, so we need our MF, which becomes 19. And then the CP of flue gases is 1.045. And then the temperature at the chimney base. This is our chimney base. If you look at it, that's our chimney base. So it's out, is the outlet. So T out becomes 225 minus T in. I think we must also reflect on the formulas on steam plant which I sent on the group so that you can get much more clarity on this. So Q economizer equals our mass times our CP into our T out minus our T in. So the temperature at the chimney base, it was given as 225. So which is our T in, the one that we need is our T in. Remember how a steam plant operates. Here we have water which is being pumped into the economizer through H1. From H1 it enters the economizer. Economizer, it leaves into the evaporator, which is our boiler. From our boiler, it goes into the superheater. From the superheater, it goes to the industries whatsoever. And then from there, flue gases are sent back. It might be in wet form or dry form. So when they are sent back here, they are now entering this becomes T in. But remember, we had already out here. Remember, these are out because superheater, it is going to the industries, wherever it is going to be used. But we still have the returning flue gases, which comes at our T in. So this becomes our T in. This is the one that we are looking for, the one, this temperature. This is the temperature which is in question, because T out at the chimney base is said to be 225. So from there, we can get our T in. Let's look for our T in. The easier way to get our T in, we can simply say 21.95 rather 96 divided by 19 times 1.045 is equal to 225 minus T in minus our T in. That's what we need, minus our T in. So we can divide here the 21.96 divided by 19 times 1.045. I'm getting 110.6 equals to 225 minus T in. So T in, it becomes the difference of the two, which is equal to 225 minus 110.6. So it's 225 minus 110.6. So I'm getting 114.4 degrees Celsius. So basically, that's how our question is supposed to be solved. The most important thing here is not about getting the right answers. In power machines, you are marked understanding the concept and how you are supposed to be presenting your work. So don't forget how you get your the temperature of flue gases entering the economizer. Don't forget that one. The temperature of the gas, of the flue gas entering the economizer. Don't forget. So our formula, I'll repeat once again. This is a very important formula. Don't forget it. So it's Q equals to M times our CP into T out minus our T in. So I hope you are going to understand this question. Yeah, thank you so much. We are meeting on the next segment. I think I'll be addressing one or two more questions on steam plant once again. But I think it's clear. Thank you so much.